Mach's principle. Look at your hand. Go on, just lift it up and look at it. It feels solid, real, anchored to you. Now wave it. You feel the air resistance, a tiny whisper against your skin. That feeling, that solidity. What if it's an illusion? What if the only reason your hand has substance, the only reason it has weight and inertia, is because of, well, everything else? Imagine you're an astronaut, floating in the profound, silent blackness of deep space. A place so empty, there's not a single star in sight. You're utterly alone. You try to spin, to pirouette. What would it feel like? Would there be any resistance? Would you even know you were spinning if there was nothing, absolutely nothing, to compare yourself to? Now, let's plunge into a different scene. You're in a vast, cosmic whirlpool, not of water, but of space and time itself. Billions of galaxies swirl around you in a grand, silent dance. As you try to turn in this maelstrom, you feel a force pushing back against you, a resistance. This is inertia. But where does it come from? Is it an innate property of your body, or is it a ghostly push from the entire cosmos? This is the heart of one of the most magical, controversial, and mind-bending ideas in all of physics, Mach's principle. To understand the magic, we have to meet the magician. His name was Ernst Mach, a brilliant and fiercely independent physicist of the 19th century. And he looked at the universe described by the great Sir Isaac Newton and said, "I'm not so sure." Newton's universe was a majestic one. It ran on absolute laws. For Newton, space was a fixed, immutable stage, an absolute grid against which the drama of planets and atoms played out. When you feel that resistance to motion, that inertia, Newton said it was because your body was moving against this absolute background space. Think of it as a ghostly, invisible fluid filling the void. But Mach asked a devastatingly simple question. How can we see or measure this absolute space? If it's truly empty and featureless, how can we prove it's there? He argued that all we can ever measure is relative motion. The train moves relative to the platform. The Earth moves relative to the sun. But motion relative to an invisible, undetectable nothingness? That, to Mach, was metaphysical nonsense. It was like saying a sound exists that no one can hear. He proposed a radical alternative. What if inertia isn't a local effect? What if it's not a property that an object carries within itself? What if it's a relationship? Imagine the universe is a silent, cosmic conversation. Every object, from a dust mote to a supercluster of galaxies, is whispering to every other object. And when you try to move, when you try to accelerate, you hear the combined whisper of the entire cosmos pushing back, saying, "Wait, not so fast." That whisper is inertia. To make his point, Mach attacked Newton's most famous thought experiment, the rotating bucket of water. Newton said, "Imagine a bucket of water, suspended by a twisted rope. You let go. The bucket starts to spin. At first, the water is still, its surface flat. But then, as the bucket drags the water with it, the water begins to climb up the sides, forming a concave shape. Why? Newton's answer: the water is rotating relative to absolute space. The concave surface is the proof. But Mach said, no. Let's run the experiment again. But this time, let's make the bucket walls infinitely thick and massive. Imagine the walls of the bucket are, in fact, the fixed stars themselves, the entire mass of the universe. Now you spin the water inside this cosmic bucket. What happens? Mach's stunning answer: the water's surface would become concave. But now, let's try the opposite. Keep the water perfectly still and rotate the entire universe, all the stars and galaxies around it. In this case, Mach claimed, the water's surface would still become concave. Do you see the profound shift? Inertia isn't about motion relative to an abstract nothingness. It's about motion relative to the total mass distribution in the universe. The stars themselves are setting the rules of the game. The distant galaxies are what give your coffee its swirl when you stir it. This is Mach's principle in its pure, mystical form. The local laws of physics are not local at all. They are dictated by the cosmic whole. This idea captivated a young patent clerk named Albert Einstein. He called Mach's principle brilliant. It became the guiding star for his decade-long journey to formulate his masterpiece, the general theory of relativity. Einstein wanted to translate Mach's cosmic poetry into the hard mathematics of geometry. In his new vision, space wasn't a static stage. It was a dynamic, malleable fabric, spacetime. Mass and energy told this fabric how to curve, and the curvature of the fabric told objects how to move. This was a huge step towards Mach's dream. In a universe with only one object, general relativity suggests that the concept of inertia becomes meaningless. That object wouldn't know what spinning or accelerating meant. It's only when other masses are present, warping the space-time around it, that inertia emerges. The frame-dragging effect, predicted by Einstein's theory, is a direct nod to Mach. Imagine a massive, rotating body like a planet or a black hole. As it spins, it doesn't just sit in space-time, it drags space-time around with it like a spoon spinning in a vat of thick honey. A gyroscope placed near it would be pulled along, its orientation changed by the whirlpool of space-time the massive object creates. The local here is being influenced by the rotating there. It's a whisper from a massive neighbor, warping the very stage we play on. But here's the twist, the point where our story becomes a cosmic mystery novel. Did Einstein fully succeed? Did he build a universe that was 100% Machian? The answer, whispered in the halls of theoretical physics, is almost, but not quite. General relativity allows for solutions that even Mach would find strange. Universes that are empty, but still have a structure. Universes that rotate as a whole. In a truly Machian universe, this shouldn't be possible. Inertia should vanish if the cosmic mass vanishes. So, the ghost of Mach's principle still haunts physics. It's not a proven law, but a profound question that continues to inspire and challenge us. And the clues we find are utterly tantalizing. Look at the farthest light we can see, the cosmic microwave background, the afterglow of the Big Bang. It provides a universal frame of reference. The entire Milky Way is moving relative to this primordial light at a staggering speed. And some physicists wonder, is this motion, this grand drift through the cosmos, subtly affecting the laws of physics here on Earth? Is the CMB the ultimate fixed stars that Mach dreamed of? Then there's the mystery of inertia on a galactic scale. The outer stars in spiral galaxies rotate just as fast as the inner ones, defying Newton's predictions. We invented a ghost, dark matter, to explain it. But could it be that we don't understand inertia itself on these grand scales? Could a deeper, more Machian understanding of gravity explain these rotations without needing invisible matter? The principle pushes us to the most radical conclusions. What if the universe is, in some sense, connected in a way that transcends space and time? What if the fact that your coffee cup has weight is intrinsically linked to the existence of a billion galaxies at the edge of the observable universe? This isn't just physics. This is philosophy. This is magic. So, let's return to your hand. Look at it again. According to Mach's breathtaking vision, the solidity you feel, the weight of your arm as you hold it up, the resistance you feel when you try to move it quickly, These are not just properties of the atoms in your body. They are dialogue. They are the cumulative gravitational whisper of every star in every galaxy, every wisp of nebulae, every hidden black hole, and every unknown planet in the cosmos. The Andromeda Galaxy, 2 million light-years away, is contributing an infinitesimal but real part to the feeling of your own body right now. You are not a solitary soul in a vast, indifferent universe. You are a node in an unimaginably vast and interconnected network. You are the universe itself, become conscious, feeling its own presence. When you move, the entire cosmos pushes back, not to stop you, but to acknowledge that you are a part of it. Your inertia is the signature of your membership in the cosmic whole. This idea shatters the illusion of separation. It tells us that the cosmos is not a collection of things, but a web of relationships. We are not just in the universe is in us, dictating the very physical laws that allow us to exist and to experience it. Mach's principle may not be a finalized equation in a textbook, but it is a beacon. It's a call to see the universe not as a cold machine, but as a living, responsive, holographic entity where every part contains in some way the whole. If this journey into the heart of cosmic connection resonated with you, if it made you see the stars and your own hands a little differently, then do me a favor. Give this video a thumbs up. It really helps the channel. Subscribe and hit that bell so you don't miss our next exploration into the mysteries of reality. And I want to hear from you. The implications of this are staggering. What does a connected universe mean to you? Does it feel more like home? Let's discuss it in the comments below. If you're hungry to go deeper, to explore a vision of reality where this interconnectedness is the fundamental rule, where the universe is a cosmic hologram and every part reflects the whole, then I think you'll love my book. It's called Holographic Multiverse, and in it, we take these ideas to their ultimate conclusions, weaving together physics, metaphysics, and the nature of consciousness itself. It's a wild ride. The link to check it out is in the description below. Thank you for watching, and remember, the next time you feel a little resistance in your life, just know, it might be the whisper of the entire cosmos, reminding you that you are never, ever alone.